The final part of this chapter on area and volume involves us looking at the area of irregularly shaped objects. And because they are irregularly shaped, it's quite difficult to get the exact area. So really here we're talking about approximating the area. And the one rule we have, the only rule that's on your course that allows you to do that, is what we call the trapezoidal rule. Now, if you take regular shapes like squares and circles and triangles, they have a basic formula for their areas. But the irregular shapes, they don't have a formula. So what we do is we take the irregular shape and we apply it to the trapezoidal rule. Now I'll go through that with you step by step. First of all, as we said to you already, it's very, very difficult to get the exact area of an irregular shape, so we approximate instead. And the trapezoidal rule will be used to estimate the area under a given curve. So if we just take a look at this particular example here, you take this red line as being the boundary, and under that is what we want to discover. We want to work out what's the area underneath that unusual red line. So what we do is we break up the distance between the ends, the terminal parts of this red line, into strips of equal width. And that's extremely important because they have to be equal width in order to apply them to the formula. So when we break up this baseline here into equal strips, we call each strip H. And then you notice that we make perpendiculars then from this wavy line down to the baseline, and these perpendiculars are called the heights as we move along this shape. So that's the first height, the second height, the third height, and so on up to y of n, which is the last height. So anytime you see n, that's just the last one. So in this case here we have width h, and it's a constant width, and we have the first height is y1, the last height is yn, and all the other heights then that are in there will be referred to in the formula. So what does the formula look like? Well, the formula is on page 12 of your tables, and it looks like this: h over 2 times y1 plus yn plus 2 times y2 plus blah 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 yn minus 1. Now, unusual symbolism, but if you look at it carefully, it's the width of each strip over 2 multiplied by the first height that you come across on your irregular shaped object plus the last height plus 2 times all the other heights that occur between these two. So y2 is the second height, and yn minus 1 is the penultimate height, or the second last height. So therefore it's the width over 2 times the first height plus the last height plus 2 times all the other heights in between. And that's the way I remember it. That's the way I would ask you to remember it. The height, the h over 2, the width over 2 times the first height plus the last height plus, that should be plus, 2 times the sum of all the rest of the heights. And I suppose the easiest thing to do is just to throw it into a question. So say we were asked to approximate the area of this particular irregular shape here. What would we do? Well, first of all, it's irregular. There's no set formula, so we can't get the exact area. So instead we get the approximate area. And all we do is we engage the trapezoidal rule. So the width here, h, is constant. It's 2. The first height is 4. So y1 is equal to 4. The last height, and we've got 1, 2, 3, 4, 5, 6. We've got 7 heights. So y7 is equal to 2. And then all the other heights in between that are y2, y3, y4, y5, y6. They will be, what will be, their sum will be multiplied by 2. So we take those into h over 2, which is 2 over 2 times the first 4 plus the last 2 plus 2 times all the rest of them added together. So 5 and 7 is 12. That's 18. That's 25. It's 28. So now 2 over 2 cancels. So we get 4 plus 2, that's 6. And 2 times 28 is 56. So the answer comes out as 62 units squared. We don't know whether it's centimetres, metres, miles, we don't know. So we just simply call it units squared. Yes, it's that easy. That's how you use the trapezoidal rule. And as I told you already, it is on page 12 of your tables. So please make sure anytime you get a question involving the trapezoidal rule that you turn to page 12, that you write down the formula like this, but that you remember it as h over 2 times the first plus the last plus, shouldn't be equals, plus 2 times the sum of all the rest of the heights that are present. Okay, let's take another example here. Let's say, for example, that this is a lake. So this is the outline of a lake, which you'll agree is highly irregular. So when we get a situation like this, we break it into 2 places. See that? Two areas. So therefore you've got the area above the baseline and the area below the baseline. And in a question like this, you simply apply the trapezoidal rule twice. So you apply it to the top, and again write it out, and you can write it out as you remember it, h over 2 times the first plus the last plus 2 times the rest. It's the easiest way to remember it. So what does that mean? That means that the h is the width, so it's a constant width of 10. So it's 10 over 2 times, we're starting up here now. The first height you'll notice is 0 because it starts at the baseline. So the first height is 0 and the last height is 0. Okay, so that will be first plus last, which will be 0 plus 0 plus 2 times the rest. So let's add up the rest using a calculator as we move along. So we've got 7 plus 8 plus 12 plus 16 plus 23 plus 32 plus 16, and that comes out as 114. So therefore 10 over 2 is 5. 5 times 228, and 5 times 228 comes out as 1140. But that's only the top part, don't forget. So for the bottom, we do the same again. And again, h over 2, first plus the last, plus 2 times the rest. Okay, in this case again, we're dealing with these heights. First height is 0, last height is 0. So constant width again is 10. So again it's 10 over 2 times 0 plus 0. Now you don't have to put the zeros in, but I'm just showing you how to fill out the formula. Plus 2 times the rest of the heights. So let's add up the heights down here. Again we've got 8 plus 7 plus 18 plus 26 plus 28 plus 23 plus 6, and that comes out as 116. So 5 times 2 times 116 is 232, and when we multiply that by 5 we get 1160 units squared. So therefore the area of the entire shape is obviously the two added together, 1140 1160, which gives me 0 3 2 units squared, and that is an approximation of that particular area. So if you get an area that is fully irregular, that means all the way around it's irregular, divide it into 2, divide the baseline into equal widths, which we call h, and then take the heights above and the heights below and simply apply trapezoidal rule twice. Okay, so this is a typical example. If you're doing honours maths, you're not going to get a straightforward trapezoidal rule like that unless you're very lucky. You'll get something like this, where they'll ask you to discover what the height is. But please remember, if there is something missing from the height or the width, they have to give you the area. So therefore, in this situation, we're told the area of this irregular. So area of irregular, what does that mean? That means you write down straight away the trapezoidal rule, which is h over 2, first plus last, plus 2 times all the rest. Okay, what do we know? We do know what the area is because we're told once we apply the trapezoidal rule to the irregular shape, the area comes out as 40 square units. So now there's only one unknown, which makes this very easy to work out. So the width, constant width is 3, so that's h. The first height is 0. The last height is 0. So again, we add up the heights in between. Now you've got 3 and 2 is 5 and 2 is 7 and 2 is 9 and x. So you can't add 9 and x together, so you put them in as a sum, 9 plus x, as an expression, and that's equal to 40. And all you've got to do now is strip this side down to x itself. So 3 over 2 times 18 plus 2x is equal to 40. And just apply your standard algebra. That gives me 3 times 18 plus 2x is equal to 80. See that? So 3 18s, we find out what that is. So 3 times 18 is 54. So that's 54 plus 3 2's, 6x is equal to 80. And now 6x is equal to 80 minus 54, and x is equal to 80 minus 54 over 6. And 80 minus 54, 80 minus 54 divided by 6, and your calculator comes out as 4.3 recurring, which is 0.323. You calculate your dot over the 3, and that's units. And that's it. So that's how the trapezoidal rule works. Now, I'm going to leave you with it because it's actually a very easy formula to use. So again, I'm going to ask you over the weekend at some stage, but before class on Monday, go through these questions, page 104, 105 and 106. They're on the trapezoidal rule. Apply the trapezoidal rule in every case here. And if there are difficulties with any of those questions, let me know by email and we'll tackle them in the live class on Monday.